Okay, so this one, I've given you the paper. Do not answer anything on this paper. I'm not grading anything that is written on this paper. What format are you going to use? Answers on the
Left.
left on the right.
Yep.
Okay. Now let me give you a. Let's go through question number 5 to kind of show you how you can do that one. So if you read question number 5, you got a force with no friction results in acceleration A when acting on mass M, then tripling the mass and increasing the force sixfold will result in acceleration O. So at this point you read that and go, wow, I don't even know what's going on. Let me give you some hints. There's 2 ways you can do this problem. Both of them start, oddly enough, with force equals mass times acceleration. So option number 1, you do smash mouth physics. You like numbers. What's the easiest force you could pick? 1 Newton. What's the easiest mass you could use? 1 kilogram. Easiest acceleration?
1 meter per second squared.
So that's how 1 Newton is defined. 1 Newton is defined as the amount of force needed to take a 1 kilogram mass and make it accelerate at 1 meter per second squared. Okay, that's how 1 Newton is defined. You saw the fan cart, okay? That was like 0.16. So 1 meter per second squared would be a bigger acceleration than what the fan cart did. So that's my initial set of conditions. Now, we're going to change it. So on number 5, what's going to happen to the mass? Instead of 1 kg, what are you going to have? 3 kg, because it says it triples it. What's going to happen to your force? Instead of 1 Newton, you're going to have 6 Newtons. So to make this balance, what's going to happen to your acceleration?
It'll have to be double.
2 meters per second squared. Okay, so it's going to go from 1 to 2. That's smash mouth physics. If that speaks to you, go with it. If you want the more elegant approach, you have F equals ma. How can you express tripling the mass? 3m. A 6-fold increase in the force. That's going to be, which means what has to happen to your acceleration? It has to be 2a. Okay? I don't care how you do it. Smash mouth physics, the elegant approach, makes me no difference. When you get to problem number 1, okay, you have to draw a graph. You can do it on your paper or you can do it separately. Make everything on number 1 positive, mainly because of the fact that you're just looking for the relationship between force and mass. Okay? Don't get wonky and make it weird and make it negative. Just keep everything positive. When you get to number 4, okay, let me kind of give you this visual. You have a scale like you all used in chemistry, but it's going to measure in newtons instead of grams. I'm going to take a 500-gram mass, and I'm going to put it on there. Okay, the first question is, what should be the reading on the scale? It measures in newtons. How are you going to get that value? Deacon, what are you going to do?
You're going to take the mass of the object and multiply it by the acceleration of gravity.
Yeah, and you're going to get 4.9 newtons. Okay? So then you're going to take a hydrogen-filled balloon and you're going to put that on there. And then the reading on the scale was going to drop from 4.9 to 4.8. Okay? Keep in mind the system is still not accelerating. So what did the forces still have to add up to? 0. So on number 4, you want to pay attention to positive and negative signs in terms of directions. When you get to problem number 5 on the back side, imagine this. You're pushing this block at a constant velocity. What do all the forces add up to? 0. You're pushing it, and then you're going to stop pushing it. As soon as you stop pushing it, what's the block going to do?
Accelerate.
It's going to accelerate because the frictional mafia is going to make it slow down. Pay attention to everything that I want on that velocity time graph. You also have some problems from the book. When you get to problems 49 and 50, I tell you I also want beyond just the force diagrams, 3 velocity vectors and an acceleration vector. And then at the end, it says and 64. So don't forget 64 on the end of that. Okay, I'm done. I know Southie people, you got to go. And we will see you all on Monday, assuming that I live through the weekend. So.
We can.
First block, they took chunks of